This is Shuttle Launch Control at T-minus 3 hours and holding. About an hour and 12 minutes remaining in our hold. Space Shuttle Discovery's journey to today's launch countdown has had a couple of challenges along the way, and here to tell us about the processing is Discovery's Flow Director, Stephanie Stilson.
One of the first things we do after the orbiter returns from a mission is remove the Space Shuttle main engines so that they may begin the refurbishment process. The yellow piece of equipment that you see here is the modified heister that we use to remove the main engines from the orbiter. Removing engines is a very slow and methodical process of ensuring everything is lined up correctly as the engines are removed from the aft compartment. Each engine is 14 feet long and 7.5 feet wide, providing 375,000 pounds of thrust during liftoff. As each engine is removed, it is transported to the engine shop located next to Orbiter Processing Facility Number 3. Engineers and technicians then refurbish the engines in preparation for their next use. During the STS-133 processing flow, the right orbiter maneuvering system, or OMS pod, was removed from Discovery to address the failed helium isolation valve issue from the previous mission. The pod was lifted to the transfer aisle prior to being transported to the hypergolic maintenance facility here at Kennedy Space Center for servicing and maintenance. On May 11th, the external tank 137 arrived by barge from the Michoud Assembly Facility in Louisiana. The barge, named Pegasus, is 200 feet long and 35 feet wide and was built specifically for transporting the external tank. Within the confines of the turn basin, a commercial tug carefully assists Pegasus as it maneuvers up to the dock. The external tank inside Pegasus is 154 feet long, 27.5 feet in diameter, and holds over 500,000 gallons of propellant. The tank weighs over 58,000 pounds empty. Once on dock, we use the external tank transporter to move the tank off the barge and over to the vehicle assembly building. While the entire offload process takes technicians and engineers approximately 2 hours, the actual travel time is only 10 minutes for the quarter-mile trip. Although the external tank looks like one extremely large tank, it is actually made up of 2 internal tanks. The liquid oxygen tank is at the top or pointed end, and the liquid hydrogen tank is at the bottom. The function of the external tank is to provide liquid hydrogen and liquid oxygen to the 3 Space Shuttle main engines. The aft bipod struts and propellant feed lines you see here connect to the orbiter. The outside of the external tank is covered in a polyurethane foam that protects it from extreme temperature variations seen during flight. Back in the orbiter processing facility, Discovery's mid-body is closed out in preparation for rollover. The yellow strong backs you see here assist the payload bay doors to close in the gravity environment of Earth. The KU-band antenna is used to transmit and receive video and data communications with the ground. The payload bay doors will be reopened again at the pad for payload installation. After spending 119 days in the orbiter processing facility, completing all required maintenance, testing, and checkout, Discovery is now ready to move to the vehicle assembly building, where it will be mated to the external tank and solid rocket boosters. Similar to the tank transporter we saw earlier, the orbiter has a unique transporter as well. The Orbiter Transport System, or OTS, has 76 wheels on 19 axles and was built specifically for the orbiter. Once Discovery is safely in the vehicle assembly building, we begin the process of lifting the orbiter off the transporter and joining it with the external tank and solid rocket boosters. Discovery is secured to the transporter using the same attach points that will eventually connect it to the external tank. There are 2 structural connections in the aft and 1 in the forward. A sling is connected to the orbiter so that cranes can lift Discovery and move it into the vertical position. Lifting the 200,000-pound orbiter requires use of a 350-ton crane and a 250-ton crane. Once Discovery is hanging in the vertical position, the smaller of the 2 cranes is disconnected, and the larger crane lifts the orbiter up and over the transom into the integration cell. It takes approximately 12 hours to lift the orbiter and get it into the mate position. Technicians closely monitor the movement of the orbiter and are in radio contact with the crane operators at all times. Once in place, the orbiter is bolted to the external tank and the sling is removed. Now that the orbiter has been mated, we are ready to move the complete shuttle stack out to the launch pad. The stack is moved by a crawler transporter which weighs 6 million pounds and uses 150 gallons of diesel fuel per mile. A unique viewing opportunity was provided to Kennedy Space Center personnel for the evening of rollout. employees could bring family and friends out to the turn basin to enjoy the beautiful view as the STS-133 stack slowly made its way to the launch pad. Instead of wheels, the crawler transporter has 8 tracks with 57 cleats per track. Each cleat weighs 1 ton. At speed of less than 1 mile per hour, it normally takes approximately 8 hours to travel just over 3 miles from the Vehicle Assembly Building to Launch Pad 39A. Discovery arrived at the launch pad on the morning of September 21st. Once at the launch pad, we spent about a month doing a full system checkout of the tank, boosters, and orbiter in preparation for launch. Here you see the STS-133 primary payload, the Permanent Multipurpose Module, or PMM, carefully being installed into Discovery's payload bay. Following final closeout inspections of the installed payloads, the payload bay doors are closed for flight. The STS-133 crew joined the Kennedy Space Center launch team for the Terminal Countdown Demonstration Test, or TCDT, in mid-October. TCDT is a full dress rehearsal of the final hours of launch countdown and provides key training for both the flight crew and the launch team. The flight crew checks the fit of their spacesuits, practices emergency evacuation procedures at the launch pad, and inspects their mission cargo in the shuttle's payload bay. This training allows them to familiarize themselves with the vehicle and become acclimated with safety equipment and procedures. Astronaut support personnel representatives assist the crew during the TCDT operations. On the morning of November 5th, launch countdown was scrubbed due to a leak at the ground umbilical carrier plate, or GUP, interface on the external tank. The GUP is located at the end of the gaseous hydrogen vent arm on the fixed service structure of the launch pad. During scrub turnaround operations, a foam crack was also found on the liquid oxygen interface flange of the tank. Both the GUP leak and the foam crack would require substantial investigation and evaluation by the Space Shuttle program over the coming weeks. The GUP plate holds a large diameter pipe that collects excess hydrogen gas from the tank as it is being filled with liquid hydrogen. The venting system funnels the gas to a larger pipe that then takes the hydrogen gas down the fixed service structure of the launch pad and out to a flare stack that safely burns off the excess hydrogen. At liftoff, the GUP retracts away from the tank, cutting off this connection. The vent arm pulls back to the tower and safely away from the shuttle. Because the GUP's connection to the tank is so important, it has sensors in place to watch for leaking hydrogen. Launch controllers track these readings closely, and if any of these readings are outside the allowable limits, the countdown is halted. After discovering the GUP leak during countdown, the external tank was drained of its liquid hydrogen and liquid oxygen and cleared of excess hydrogen gas. At that point, it was safe for technicians to begin collecting data to better understand and analyze the leak. An investigation team was formed to fully evaluate the hardware configuration, installation, and functionality and determine if any modifications would be necessary. Teams performed an initial inspection of the flight seal and quick disconnect prior to sending them to the lab for extensive micro-level inspections. As part of the investigative effort, the complete ground umbilical carrier assembly and vent line was disassembled and inspected. The same repair is performed on the other cracked stringers found at the launch pad. In addition, a radius block modification was also performed on the inner tank stringers. The radius block modification provides additional structural support in areas known to carry much of the structural load of the external tank. These radius block essentially fit over existing stringer edges through which securing rivets are installed to provide additional structural support. Once all repairs were made to the external tank, the stack was again placed atop the crawler transporter and carefully rolled out to Launch Pad 39A on January 31st. Brilliant xenon lights illuminated the vehicle, creating a spectacular view for everyone present. To verify the integrity of these repairs, an instrumented tanking test was performed on December 17th. Numerous strain gauges and temperature sensors were installed to record data from the tank as it chills and warms again during the loading and offloading of propellants. Following the completion of the instrumented tanking test, we rolled the shuttle stack back to the Vehicle Assembly Building for further non-destructive evaluation, or X-rays, of the external tank stringers that were not accessible at the launch pad. Rollback occurred on December 22nd, and engineers immediately began inspecting and evaluating the external tank. X-rays revealed an additional 4 small cracks on 3 stringers. These stringers would require the same repair as performed on the other cracked stringers found at the launch pad. In addition, a radius block modification was also performed on the intertank stringers. The radius block modification provides additional structural support in areas known to carry much of the structural load of the external tank. These radius block essentially fit over existing stringer edges through which securing rivets are installed to provide additional structural support. Once all repairs were made to the external tank, the stack was again placed atop the crawler transporter and carefully rolled out to Launch Pad 39A on January 31st. Brilliant xenon lights illuminated the vehicle, creating a spectacular view for everyone present. Once back at the launch pad, a full system checkout of the tank, boosters, and orbiter was completed in preparation for launch. STS-133 is the 133rd Space Shuttle mission and Discovery's 39th and final mission.
Thank you very much, Stephanie. It's nice to have you here in the firing room next to us today.
It's great to be here. Launch day is always a good day.
It is a good day. But this has to be a little bit of a bittersweet moment this time around since we're talking about Discovery's last flight, and you've been with the Discovery team for a long time as the flow director. How does it feel today?
Well, you're right. It has been bittersweet. Whenever we achieve major milestones along the way, say rolling out of the OPF, rolling out to launch pad, there tends to be some tears there, tears of joy, excitement to be past that major milestone. This time around, there was a little bit of an underlying sadness as well because it's the last time we're going to be processing Discovery for flight. So the team, although excited about being here on launch day, there is some emotion, and I expect that when we lift off today, we'll see quite a bit of emotion here in the firing room and with the rest of the processing team who are outside with their friends and family ready to watch liftoff. And
it will be another emotional moment when Discovery lands back here at Kennedy Space Center in about 11 to 12 days. When that happens, what will happen with Discovery?
Well, what we'll do initially is basically business as usual. We go into what we call our down mission processing. And basically that's about a month worth of work where we're first safing the vehicle, getting it back into the orbiter processing facility, draining hazardous commodities so that we can get access to the vehicle and put personnel in there. At that point, the main thing we're looking for is there anything with Discovery that we saw on orbit or in inspections that we do on the ground that would require us to go do anything different on the other 2 vehicles that still have a flight to go. So we'll do that, do those inspections and so forth. At that point, then we get into what's the new part of our job, and that'll be the transition and retirement of Discovery. And the first stage for that is called the in-state safing. And basically at that point, the vehicle has been safe enough for technicians and engineers to work on it, but now we need to make it safe enough for the general public to be around and close up with the vehicle itself. So there's different commodities that we'll have to offload to ensure hydraulics, ammonia, cryogenics, those hypergols, those kind of things, as well as pyrotechnics and so forth. So we'll take care of that. At that point, we'll also look to pull out the main engines. Those will be removed and reused. We'll also have pulled out payload components that are necessary. And then there are going to be some avionics boxes and components of the vehicle that we pulled out and used for future type of research or future projects and things like that. So we'll do that. The next stage then at that point is to prepare Discovery to be ferried to the display site. So we'll have to put the OMS pods and the forward reaction control system back on, put engine simulators in and so forth, and get it ready to go out to the mate-demate device out by the runway, load it up on the shuttle carrier aircraft, and then ferry it off to its final destination. When we get there, we have the task of then offloading from the SCA, taking Discovery into its display area and doing the final touches to get it into a preparation for being displayed by the general public.
And your team will be involved in all that process?
Absolutely. All the folks that have worked on all the vehicles throughout the history of the shuttle program, same people, engineers, technicians, quality, safety, planners, schedulers, they'll all be involved with this transition retirement activity as well.
That's great. Well, since your team has been working so hard on this shuttle for so many years, some folks came up with an idea. There's a traditional liftoff line that the Public Affairs Office commentators utter at the time of liftoff, and your team was asked to come up with a liftoff line this time to be used at the time of liftoff. Can you tell us a little bit about that process? And,
sure.
And without revealing the line, maybe...
Yes, I won't steal your thunder and read the line by any means. No, what a great honor to allow the team to come up with that final liftoff line. And so basically what I did was I sent an email out to the leads of the Discoveries team to basically describe what we were looking for and give examples of previous liftoff lines, the criteria and so forth that go with that. And then all the leads then dispersed it out through email to all their distribution lists. That's the quickest way we can get the word out, is via email. At that point, then individuals were able to submit those ideas to me, and I consolidated them and passed them on. And then the selection committee actually was able to pick the one they thought was best, and I think they did a real good job with that. And are we allowed to say whose selection was?
Yes,
okay.
please do.
Mary Butler of the United Space Alliance was the one who submitted the winning liftoff line, and Mary has been with United Space Alliance working shuttle since '96. She's in the guidance and navigation group, so basically she does all the systems checkout and testing of the navigation systems and radar and so forth. And she's actually a member of the Prime launch team, so she's in here today getting ready for liftoff. And her husband John as well is also on the Prime launch team. So really excited for Mary to have submitted that, and we're really excited to have everybody hear it.
Yep. Well, we're going to be excited to speak it. So that's wonderful, and we really appreciate Mary's line and the effort that your whole team put in on coming up with those liftoff lines. There were a lot of good ones, and it was a hard choice for the selection committee.
I can imagine. We're all very excited and very proud to be part of Discovery's team. So thank you for talking to me today.
You bet. Thanks again for being with us, Stephanie.
You're welcome.